The threat detection system. Whenever you go out on your own, you inevitably sacrifice a bit of security. It is simply impossible to be totally aware of your surroundings at all times. Everyone knows this on some level, and that fear prevents us from living out our full potential. From a study conducted in 2014, it was discovered that 45% of women and 27% of men would not feel safe walking alone at night. A 2017 poll from Runner's World found 30% of women reported that they were followed by a harasser on their run. Whether you are a jogger, biker, elderly, or visually impaired, we want to provide you and your family with the peace of mind that only can come from having someone there to watch your back.
So here we have a glimpse into our hardware and PCB design. On the left is a picture of our PCB with no components, which was developed using Eagle CAD. On the right is our PCB design with all the parts soldered on. Our circuit on the PCB is fully functional, so the next step in the hardware will be to construct a housing for the circuit.
So identifying the components used in our design, the first component you see in the bottom left corner is the switching voltage regulator. Using the switching regulator will help us conserve power. The next component is the ultrasonic sensor. We designed this to be at the edge of the PCB so the parts emitting and detecting signals can sit outside of the housing. The next component is the HC05 Bluetooth module. This will connect to the user's phone and help with connection to the app. In the back is the AppMega 328 microcontroller, which is holding all of our code. The last component we used was a power switch to turn the device on and off.
Okay, so now we're going to talk a little bit about the code that's on the microcontroller of our smart sensor module. At the top, we're using just two libraries, and then we have some definitions. So one of the libraries, the new ping.h, allows us to use the ultrasonic sensor with only one GPIO pin on our microcontroller. And so we're going to be using pin number 7, as it says there. And then our sensor only has a maximum range of about 500 centimeters, so I just put that as our max distance. And we're actually sending, once we detect a threat from the sensor, I'm going to send an alarm code, which is the 3F there, over Bluetooth to the app on the user's phone. So here, next we're going to define this instance of sonar. Is just a way that we can communicate with the library that we're using there. And then just some more definitions and pin definitions and variable declarations. And then for the setup function, I'm just using the serial port, and we're using the baud rate of 9600. And then the LED there, that's just as a test code for me. Next, we're going to get into our main loop. So first we're checking to see if there is a serial connection. And so if there is, then we're going to continue with the rest of the loop. If not, we're just going to loop back to that same statement and keep checking it until there's a connection. And next, we're going to declare a loop variable, and then we're going to declare a matrix which we'll be inputting our distance values into. And so I have a for loop that only has 2 iterations to get the reading and then wait a little bit of time, so I have 100 milliseconds. So get the first reading, wait 100 milliseconds, and then get the second reading, and then populate those into the matrix. And then continuing on with our main loop, I'm going to take the difference of those 2 distance values that we collected, and then if the difference is greater than 0, meaning the object is approaching, then we increase a flag by 1, and then if the difference was less than 0, meaning the object was retreating, then we're going to set the flag count to 0, setting it back, just clearing the numbers, clearing the flag totally. And then we have another if statement, which is reading the value of the flag, and if the flag gets past a certain point, and which I set to 3 here, we're going to illuminate the LED. That was just for my test code. But the main thing is we're going to send the alarm code, that 3F from the top. we're going to send a 3F over the Bluetooth to the user's app on their phone. And so that'll initiate the whole code process on the app side. And then else, so if the flag is less than 3, I just had an LED being set to low just so I could test it without using the app every single time.
Here we can see the sequence of operation of our Android app. First, the user sets their emergency contact in emergency message. The app then continually monitors the status of the smart sensor. If a 0 is received, then nothing happens. However, if a 1 is received that a threat is approaching, a timer will begin. If the timer is not disabled within 15 seconds, the application automatically sends the emergency message to the emergency contact. Here is a snippet of the code from our Android app. This portion of the code is responsible for the timer that controls the sending of the emergency message. Assuming the system is already connected to the Android device and the alarm sound is not already playing, if the application receives a signal from the system or the previously mentioned 1, the alarm will sound and the timer will begin. This portion of the code controls the sending of the emergency message. If the alarm is not disabled within 15 seconds, the message is sent to the contact and the alarm is automatically disabled. If the user wishes to send the message to the contact without assistance from the actual system, they are able to tap the Alert Contact button, which will immediately send the message.
As we can see from the flow chart, this is our work division, with Eric as the team leader, Nathan as the technical leader, and Kwok and Michael spearheading the app development. The work on this project was spread pretty evenly amongst the 4 of us. Thank you for listening, and now we present to you a short hardware demonstration.
Alright, to begin, you can see I have Nathan currently set to my emergency contact with a message help. If Nathan begins to step towards the device, you can see that the alarm is going off. If I hit stop, the alarm stops and no message is sent. However, if he steps close to it and the alarm goes off, and I don't press stop before 5 seconds is up, then a message gets sent to Nathan, and we can then stop the alarm, and from his phone, we can see that he has received the text.